All right, here we have example 2. We see a little bit different picture of the altitude here. An altitude can be drawn by extending a side out and then going perpendicular up to the other vertex here. But you always see that right angle with the altitude here. It makes that right triangle too in there. This time it's outside the figure. So we can see that the base is 12 here, 12 meters. The height is 4 meters, so we got our base and height. We can go right to our formulas. Go to area is base times height. 12 meters times 4 meters, or 48 square meters. Put your units in. And then, of course, our perimeter, we've got two sides that are 12, 2 times 12, and we have two sides, not that are 4, they're right here. This side here is 5 meters. And we end up with 2 times 12 plus 2 times 5, which equals 34 meters. Okay, not so bad there. Let's take a look at the next one. Your quick check here. Now the height is back inside here, but like you see, we don't know it. Well, let's write down the base. We have 21 centimeters here for the base. We're going to have to figure out that height again. We know this side is 6 centimeters and this one is 10, so we're going to figure out this height using Pythagorean's theorem again. Good practice. So here's our legs, here's our hypotenuse. Leg squared plus leg squared equals hypotenuse squared. So we have this leg squared plus this leg squared equals the hypotenuse squared. I got that minus 36 a little early. I squared them right here. So 8 squared, squaring these. 6 squared is 36. 10 squared is 100. We'll isolate, get that 8 squared by itself by getting rid of that 36. We end up with 8 squared equals 64. And then we take the square root of both sides. That cancels out the square on the h. We get h instead of 8 squared equals 8 centimeters. So the height here is 8 centimeters. Now we're ready to go to area and perimeter. Area base 21 times the height 8, 168 square centimeters. The perimeter, 2 times this side, 2 times 21 centimeters, plus 2 times this side, the 10 centimeters, equals 62 centimeters. Now, you know Mr. Yeager makes mistakes once in a while. If you see me making a mistake on any of these numbers, let me know. All right. Pause them anytime you need. Call me over if you need help. Let's check out the next one. Example 4. Well, let's see. Yep. This is example 4. Now it says record exact and approximate answers rounded to the nearest tenth. We aren't going to do exact. We're going to do the approximate. We're going to round to the nearest tenth in all our problems, okay? Not going to worry about exact, so you can get rid of this right here. We're going to do approximate. Now this one involves some trigonometry, you'll see. We'll go back to it and remind you of it and see how you do. Let me know if you have some questions. Remember, when we do trig functions, you have to have your calculator in degrees because we're using degrees. So hit the mode and highlight degrees and make sure your calculator's in degrees. All right, what do we got here? Well, I can see this side is 6, so this other side is also 6 right here. That is the base. We do not know the height, but we know our base is 6 units. They didn't put in centimeters or inches, so they always put in units right here. You'll see that area will be units squared, whatever they are. Now to figure out this height, I've taken this triangle, this right triangle part here, and moved it over here so we can look at it. We know this side is 4. There is no way to figure out this little piece here. All we know is this whole side is 6 on this parallelogram. So we're going to have to set up a trig function because we don't know two sides of the right triangle, so we cannot figure out the third using Pythagorean's theorem. So we look up here, let's see what we got. We're going to label these sides, was the first step when we use trig functions. I remembered this side is the hypotenuse. Opposite this angle is this side over here. Height we're looking for. And so the third side right here is the adjacent side. Then we figure out which two sides are we going to use in our trig function. We need 2 for that fraction. And of course we have to use this side because we want to know h. And we have to use this side, the hypotenuse, because it's got a number. So which trig function used opposite and hypotenuse? Yeah, you can remember SOHCAHTOA, sine opposite over hypotenuse. So we are going to use the sine function. Let's see if I can find it. Oh. Here we go. The sine of the angle, 60 degrees, equals the opposite side, h, over the hypotenuse, 4. And then we remember we went ahead and put it over 1 and cross multiplied. 1 times h is h, and then 4 times the sine of 60 degrees. So we'll do that step now. 1 times h is the h. 4 times the sine of 60 goes on this side. Remember, put the 4 first, times the sine of 60. So it's solved for h. h equals 4 times the sine of 60 degrees. Which rounded to the nearest tenth, check that, will round to 3.5. So the height of this is 3.5 units. So now we have our base and our height. We're ready to multiply them. Area, base, times the height, which comes out to 21 approximately because we rounded. And then the perimeter, this side is 6, 2 times 6, this side is 4. Oh, I messed up here. Someone could have caught me. So I'm going to have to fix this. I put in the height instead of the length of this side. That can happen when you're not paying attention, Mr. Yeager. So this should really be 2 times 4. So let's see, 2 times 6 is 12, 2 times 4 is 8, 12 plus 8 will be 20. So watch out for the mistake I just made, not paying attention enough. Here we're doing perimeter, yeah, 2 times this side, 2 times this side, not the height. All right, let's pause that and go to another part.